Okay, we're all set. So is my voice clear? Can someone confirm from the?
Yeah, we're
Yep.
still having new people coming in.
That's fine. We'll just wait. So I don't mind
Yeah.
starting a little late if people join. It's no
Yeah,
problem.
we're having the theme songs now.
Thanks, Mohammed, for putting the alert. Thank you. Okay. So I just made a kind of like an attendee starter pack of sorts where you can find the link to the code and uh, so I'll just share it over here. It's fine if you don't understand the code right now, but I'll be I'll be explaining that in detail. So here's the link, and if you haven't checked in, there's a check-in form as well. So to mark your presence in the study jam. Okay, we have Mahmoud from Dhaka. And we'll start another 3 minutes. So if you haven't made a GitHub account, right? So you can just make an account. Hi Avinash. Okay, so you're from Pune. It's not too far from Bangalore, and you can just make a GitHub account, but you don't need to necessarily know about GitHub and how to use that. So I'll be showing you that as well. And yeah, it's going to be a really interesting session, and there are going to be many takeaways from this session for all of you. Like if and the basic knowledge you require is just some basics of Python. That's it, nothing much. And it's good if you would like to follow along with me to have Python installed in your system. So it's really good. But I'll be sharing the recording, so if you don't have it right now, then it's completely fine. You can watch the recording later and code along. I think Mohammed, yeah, I just checked the audio. It's fine. I think you'll need to connect your audio or change your device. I think that you can listen the. Okay. So I hope the Google Doc link is working, and all the code is there. But yeah, if you don't understand anything right now, then you can just listen to me. So we'll be starting at exactly in another 1 minute. So the session is for 1 hour, but I'll take some questions as well. So towards the end, right, about 15 minutes, I'll be taking some questions. And since we have, the next session will be starting in uh, another 1.5 hours, right? So we'll have some gap as well. So around 15 minutes of time, so we can just use that time as well if anyone's interested in asking any questions, or if I'm clearing doubts, right? So I'll just we can just extend the session a little more. Hi Ivan. Hi Oliver Tosin. All right, so I'll just will be starting another. Okay, so it's exactly 2, and I'll just start the session. So I hope everything is audible, right? I hope everyone can listen to me except for Jamal. I think there's a audio issue on his end. All right. So my name is Vedant, and I'm a freshman year undergraduate studying computer science in India. So today I'll be talking to you about a very, very interesting topic and a necessary topic, which is often neglected, I would say, and is one of the toughest or difficult tasks which a data scientist or a data analyst does in his day-to-day life, which is deployment. So deployment is one of the stages of a data-driven project. So anything which relates to data, right, has to be deployed so that it can be easily used by the world. Okay, so users from all over the world. So let me give you a case study on how. So deployment is basically you make an application, a web application, or like an Android app or anything else which can be used by the people. So you have to make it interactive so that it can be used by anyone who knows about data, who knows Python or anything else, right? So it doesn't matter, but it should be usable. So our product must be usable. So let me just give you an use case over here to like make you understand why is deployment or building a web application or building an Android app so important. So let's say that we have built a model. So I have built a model that predicts lung cancer. So basically my model takes in some images which have of the lungs, and the images can be either they will be labeled, and they can either have lung cancer or they cannot have lung cancer. So I'll have a labeled data set. So it's basically will be this particular image shows signs of lung cancer, the other image doesn't show, and so on. So I'll just train my model on that, and then I'm going to predict if some other unknown image, right, so alien image to my model has lung cancer or not. So this is the project which I'm going to build. But if you observe closely, right, so if we are going to write some code on using IPython notebooks or using Google Colab or even an Alteryx workflow, right, so do you really think it will be useful for the end user? So let's say that a doctor wants to check if his patient has lung cancer or not. So we can't tell him to like change the code, change this line of code and upload a image over there and check if it has lung cancer through running or by running our model, right? So that's literally not possible, because it's going to be a tough ask. So if our model has accuracy of around 98% or 99%, it's of no use if the world cannot use it, if the doctors cannot use it, if the hospitals cannot use it for their own good, right? So to predict accurately if a person has lung cancer or even save his life. So for this purpose, the deployment phase comes very handy. So deployment, basically in this case, what we can do is build an application where we have a simple file upload, like a place where the people can upload their file or an image, right? So we just have a file uploader like your Google Drive, right? So you upload something from there. So if you upload an image of a lung, so lungs, pair of lungs, and you feed it to our model, so it just shows a screen. You have a UI interface, and it tells you within a matter of seconds if it has cancer or not, something like yes or no, or red or green color, right? So something like that. So this, as you may have already thought about, is a very, very useful way of conveying information to the end user who doesn't know anything about what our model is doing on the back end. So it just abstracts the model and just gives it a really clean interface. So we will not be building an application to predict cancer over here. That's something really difficult to do, and it's really hard to get an accuracy of around 100% or even 90% in case of many applications that predict cancer. But today what we'll be doing is actually building an application which will predict the prices of diamonds, right? So we'll be building an application that is completely based on the diamond price prediction project that we did in one of the lessons of the foundation course, and it's going to be really amazing. So you guys can follow along with me, and I'll also share the Google file link where you can get the all the code as well. So let me just quickly share that and we'll begin. So I have divided the project into like a small chunk so that anyone can uh, understand what's going on. So let me just switch to my VS Code, and . 。 . 。 . 。 . 。 . 。 . . . . . 。 . . 。 . . . . 。 . . 。 . . . . 。 。 . 。 。 。 。 . 。 。 。 . 。 。 。 。 。 。 。 。 。 . 。 . 。 . 。 . 。 Okay. Jesse, can you confirm if you can see my code, the black background? Can someone confirm? All right. So I'm getting a lot of yeses. So let's begin. So
Yes.
thank you. So let's begin. And if you have any questions, right, so you can put it in the chat because I have another monitor here to monitor the chat as well. And so we'll be building this application in like bite-sized pieces. Okay, so everyone can understand what's going on over here, irrespective of whether they are machine learning experts or data analytics experts or not. So the first thing we'll be doing is working with an application called Streamlit. So let me just give you a brief explanation of how Streamlit works, and I think you can see the Streamlit website. And Streamlit is basically an API or a package, right? So package is nothing but it allows you some functions which you can use to build your application. So you don't need to write a lot of code to do something. So Python packages allow you to build things faster. So Streamlit is basically the fastest way to build and share data apps, as it says over here. It simply turns all the data scripts into shareable web apps in minutes, and literally in minutes, and all in Python, all for free. You don't need to know any front end experience at all. So you don't need to know HTML, you don't need to know CSS, JavaScript, and all that, all those things. So all you have to do is you can just get started in a minute, and you can follow along with me. But as I'm recording this session, you can also watch it later as well. So you can just run pip install Streamlit and just install Streamlit in your system in a matter of seconds. And Streamlit basically builds on three simple principles. So one is embrace scripting. So Streamlit is basically it builds an app with just a few lines of code with the magically simple API. Okay, so it just has an API running in the background, so you can't see the complex code which it's running in the background, but you can just see the okay. Just switch off my camera because the bandwidth is low, and you can just use Streamlit to make simple application apps, or do some simple functionality without having to write a lot of code. So here is one demonstration. So you just import Streamlit into your Python file. So importing is basically telling your Python file that I'm going to be running Streamlit over here, and you can also import the other packages which I'll be talking about later, and using write. So st.write, right? So using the write function, which is like quite intuitive. So write basically prints or display something on your console. You can just print my first app, hello world, over here. So this is the markdown syntax which some of you might have heard about, and we can just import our data. So read underscore csv is basically importing our data, and using just one line of code, which is st.line chart, you can just plot a line chart over here. So it's cool, right? So with just so many lines of code, around 6 lines of code, you just made your simple application without using HTML, CSS, or JavaScript, or not worrying about all that. And the best part is that it allows you to do a range of features, like you can use this line of code to pick a number, certain number, right? So 52, 53 or something, and you can use that as an input to your machine learning model. So I'm going to show you that. And don't get me wrong here, but you don't really need to implement machine learning models while deploying an application. So even if you're a data analyst, right, you can show your plots to the world by deploying it on Streamlit. So you don't need to necessarily use machine learning. And so on, you can also pick a file over here, like I mentioned in the lung cancer case study, right? So you can just call file uploader and ask the user to upload a file, and you can do a lot of things. So calendar is one, and now comes the most interesting part, which is deploy instantly. So with just a snap of a finger, right, so it deploys your application to the net. So it gives you an URL which you can share with anyone. So you basically run just don't need to run the code at all. So you just drag, drop, and then upload, and then your application runs in a matter of minutes. So snap, and your application is on the net for anyone to see. So we'll be doing this as well, and that's all. So this was a brief introduction to Streamlit, and now let's get to our actual application. All right, so I'll just go to the first file. So can everyone see my the VS Code environment? So I think that's visible.
Yes, absolutely.
Sure. Okay. So the first thing we'll be doing is importing Streamlit. So importing is basically telling your Python file that we are going to use Streamlit in our application. So we are going to import Streamlit as st. So st is basically an alias. So when we are calling some predefined functions of Streamlit, right? So instead of using Streamlit dot something, we can just use st dot something over here. So that's basically we are going to import Streamlit over here. And now what we are going to do is we are going to create certain containers. So containers is basically going to be sections of your page. So each container will contain some idea, some things about your page, right, about your project. So that's done using the beta underscore container function. So Agnideep is asking if we can use Jupyter. I don't think Jupyter's there's Jupyter support for Streamlit yet. So you can just stick to VS Code or any other code ID. I think that would be better. Yeah, and so beta container is used to create a container or basically an area or section of a page where like you can put some or your text or your images or various other things. So I'm going to show you how to do that. So here we have one container for a site header, one for the data source, one for data exploration, and similarly one for model training and the linear regression. So I'm going to show you how you can put text or different kinds of images, plots in these containers. Okay, so now what we are going to do is we are going to specify with site header. So with site header basically says the Streamlit that we are going to put some text, or we are going to do some run some functions of Streamlit for the site header container. So basically what we are specifying with is that we are going to use the site header container and put some text or write something in that particular section of the page. So you can use st.title and give a title to your page. So you can see that diamond price prediction ML project. So I'll just run this in a couple of minutes, you can understand it better. And you can use title to give a title to your page, and write is basically used to input text, like you can show text or plots over here, which basically describes your container or section of the page. So you can see that in this project we are going to predict diamond prices using the random forest and linear regression model. So I'll be talking about random forest later, also linear regression models. And similarly what I've done here is that you can specify with data source, and then you can give the header. So you can give header or title, it's nearly the same thing. You can give a header and say data sources, and you can write something. So this is basically the body of the so Jens is asking if why am I going to use random forest. So I'll be explaining that in another 10 minutes time, so you'll just understand why I'm going to do that. And yeah, so you can just write about the body over here of the container. So I'm going to use two different data sources. One is going to be the diamonds.csv file, and the other one is going to be new diamonds from the Udacity course challenge. So similarly, I have created different containers here for data exploration, where we're going to explore our data, and one is for the model training and the other one is for the linear regression. So all these are basically the containers which you are going to use. And now the way you're going to run the application on a local system is you'll have to open your terminal or your command prompt, and once you have Streamlit installed, right, so you have to run Streamlit run and the name of your file. So you can just say the name of your file .py. So Streamlit run one.simplestructure.py. So you'll have to run this command once you have Streamlit installed in your system. And if you press enter, so it's going to take some time, 1 minute or so. And okay, so now you can see that our application is basically going to run on localhost 8501. So it automatically opens the project in our local system, and you can see that we get a super simple application with just so many lines of code over here. So you can see we have our title and we have our data sources, we have our let's explore our data container open, and then we have model training and the linear regression model. So we'll be focusing on these three things today, and if time permits, I'm also going to discuss about how you can implement the linear regression model as well. So I cannot see anything in the chat as of now, so I'm just going to continue. And now that we have a simple skeleton for our application, right, so now we can actually import our data and do some analysis on the data. So that's what we're going to do in the second part of the application. And as the first part, I'm going to import Streamlit and Seaborn. Seaborn is basically a package which is used to plot data or visualize your data, and pandas is used for performing various operations on your data. So you don't need to learn about know about all this, but my sole idea is to get your application running on Streamlit, so that if it doesn't matter if you use machine learning, you don't use machine learning, use Python packages or not, so it doesn't matter, but you can run any application on Streamlit. So I'm basically going to import all these packages over here, and I'll explain why I have done it in a couple of minutes. So as usual, I'm just creating two containers over here. One is for the data source and the other one is for the data exploration. So I'll be combining like all these sections together in a single app. So here you can see app.py, right? So I'll be I'm going to compile all the code over here later on, but I'll just divide into small chunks so that you can see what's exactly going on, rather than a big document, right? Like a huge document. Okay, so now I've specified with data source over here, and it's basically telling Streamlit like, hey Streamlit, I'm going to put some content in my data source container, so or a section of data source. And here I've given an header called data sources, and I've just given a small body or a description of what it's going to be in this particular section, which we did in the previous a simple structure.py file as well. And now what I'm going to do is I'm going to read the CSV file into our Python script. So read.csv basically imports, so it's like the input tool of Alteryx. So it's similar to the input tool of Alteryx, and it basically imports your CSV file into the Python script. So you can just use pd.read csv. So pd is basically for pandas, so we are just given an alias name, and pandas allows us to read or import our CSV file into a Python script. And that's what I've done over here. And now what we are going to do is look at the number of rows and number of columns which are present in our data set. So I just given st.write, the shape of the data set is, and now you can see the familiarity with Python syntax, right? So it's exactly similar to Python, and this is basically acts like and this is basically it basically acts like a variable. And dot shape is another function of pandas which allows us to look at the number of rows and columns of the data set. So you don't need to get intimidated about this, and like you don't need to learn everything right now. So you can also DM me about this later if all this is very alien to you, right? So you just need to understand that here in this line of code we are printing how many how many columns are there and how many rows are there in the data set. So let me just run this as well to show you. So I'm just going to run Streamlit run and the name of the file. So I'll just run this and show you the output. Let me just check if there are any questions. So it does work in Sublime Text, Antonis. I've checked it out, and there shouldn't be any problem. Yeah, so I think Jens has clarified a few doubts over here. All right, so I don't think there are any doubts over here. And yeah, now you can see that we have the number of rows and the number of columns over here printed out. So if I switch back over here, you can see diamonds.shape, right? So shape basically prints out the number of rows and the number of columns in a tuple. So tuple is basically a data structure, and you can see that we have 50,000 rows over here, and we have 8 columns. All right, and okay, let me just get the thing running again. And so similarly, what we are going to do is, if you want to actually see the first 5 records of the data set, right? So if you want to see the first 5 rows which are present in your data set, you can do that using the head function of pandas. So head basically shows you the first 5 records of the data set, and you can display it to the screen using st.write. So you can pass in any functions over here from any Python package using st.write, and it just displays to your screen. So now over here you can see that I've given the first 5 rows of the data set are. So it just shows you the first 5 rows of the data set. Now this is cool, right? So you can just give a brief description about your data set over here, and it just prints it to the screen. So you don't need to use HTML, you don't need to use CSS, you don't need to use JavaScript. Just one single line of code. So it's really cool and mind-blowing. And the next thing I'm going to do here is describe the data set. So describe function is another function of pandas which gives you various statistical measures for a data set. So again, I've displayed it on the screen using st.write, and you can see that we have different statistical measures for our data set. So you can see that caret has a count, so the number of records for caret in the data set is 50,000, and so on for the others as well. So there are no null values in this data set, and you can see that the mean value over here is some numbers over here. So you have the standard deviation, you have the 25th percentile, you have the 50th percentile, 75th percentile, and so on. So using this one line of code, you get all this data. So it just single line of code, so you get all this data over here. And now what we are going to do is actually run or perform some exploration on our data set. So we are going to check the correlation of a data set, we are going to draw scatter plots, we are going to do going to be drawing heat maps and so on. So like in the previous structure.py, I have just shown you the header and the write over here. So this is the same thing, and now I'm going to import my data set over here. So you don't need to do this, but I don't know why I've done this over here. So you don't need to necessarily do the code on line 37. Now we are going to check the coefficient and the p values for caret versus price. So over here I'm just going to use one input features, but previously in the project we have used a couple of other input features as well. So here I'm just going to use one input feature for simplicity, and we can check the correlation using the Pearson correlation using the scipy.stats package. So if you call scipy.stats.pearson r, so if you call this particular function on two values x and y, right, so it just shows you the correlation between the two values in the data. So let's just check what is it. So here you will get to know the correlation as well as the p values for the two input features. So those are the two things which are displayed as a tuple. So here you can see that we get two values. The first one is the correlation and the second one is the p value. So the p value is 0 over here because the data is overfitted, which basically means that the data is like it works really well, almost an accuracy of 100% on our training data, but eventually it will just fail on our test data. So if you give some new alien data to it, right, so it's going to fail. So don't worry about the p value, but you can see that we have a really decent correlation value of around 0.921 for caret versus price. And now the next thing that we're going to do is basically draw scatter plot of caret versus price. So the first thing how this works is that you don't need to know about all these things if you're not really into Python, but I'll just tell you how this works. So the first thing you have to do is call the PLT function. So PLT is basically another another Python library which helps you visualize your data set. And you need to call the figure function on that, which basically draws an empty plot for you. So it just shows you a plot with no data in it as of now, no data plotted. And the scatter plot function of Seaborn, so Seaborn and Matplotlib are two packages over here. So again, you don't need to worry about this if you're not in depth about Python. So you don't need to learn. If you're not learning about Python, then you don't need to worry. But I'm just showing you how you can do this using Streamlit. So here I'm going to plot the caret versus price. So the scatter plot for caret versus price. So we are getting the two input features from the diamonds data set. And here what we are going to do is basically plot the scatter plot, but not actually display it. I know it gets a little confusing over here, but you can always do a Google search or refer to this recording again if you're not understood about the exact syntax. But all you have to understand now is that it's going to plot a scatter plot of caret versus price, and we are going to display it over here. So these are the three things that we are going to do. And let me just run the app again. So I'm currently using the newest version of Streamlit. So some of the features might not work on Streamlit. So pardon me about that. So I like a fool just like updated my Streamlit just before the webinar. So now it's kind of working over here. So you can see that we have a scatter plot of the caret versus price, and as you may have noticed, we have a linear plotted, so it's like a linear graph over here. So it's perfectly excellent for our the models, the regression models which we are going to plot. And similarly, what I've done over here is that okay, let me just so similarly what I've done is that I've also plotted the correlation between the different features. So we saw that the caret versus price, the correlation is 0.92, right? So if we want to check the correlation of the other features as well, so we can just plot a heat map. So heat map is basically it shows the correlation of each feature or each column in our data set with the other column. So that's what I have done over here, and I have plotted it. So okay, so just run the application again. So you need to run the application multiple times over here because it's running on our local system. But once you have it running on the internet, right, so if you have a local URL for that, so you don't need to actually keep running the Streamlit the command again and again to run the application. Now you can see that we have a really beautiful heat map over here, or the correlation map as it's called. And you can see that the correlation for caret versus price is almost 1. So it's really high. So it's almost 0.921 to be more precise, as we saw in the previous the container as well. So you can see that it's almost 1. So the caret is a perfect fit for our model to predict the price. So the way you interpret this is that you go from caret to the x-axis, and you can just check the price on the y-axis. So over here you can see that caret versus price has a really high correlation value, and whereas caret versus something like cut ordinal doesn't have a really high, or it has a really low correlation value. All right, so I guess everyone's helping each other in the chat, so I'll just continue right now. And the conclusion we can draw, so I'll just show you the code for the conclusion as well. So you can just draw a subheader as well. So if you want a header right in the top, and you want subheaders for each section, so if you want a subheader for the data source, you want a subheader for the data exploration, you can give it using the subheader attribute or function of Streamlit. So you can see that we've given a subheader of conclusion, and we've just given some description over here. So let's just go to the application, it will be more clear over here. And you can see that caret has a linear relation with price, so it can be a good input for our linear our regression models in general. So it can be regression, or it can be random forest model as well. because it has a low p-value. So in our case it's 0, but it's not actually 0. In real life data you never get a 0 p-value, and it has a really high correlation, which is possible. 0.921 is a really good correlation, and so it can be used as an input for our model. So Saurav is asking if Streamlit supports dynamic data views in the form of sliders, buttons. Yes, Saurav, I'm going to come to that right now. So you asked the right question, and I knew this question is going to come. So let's just switch to our VS Code, and let's move on to the model training part. So for this part, right, so we'll be using two models. So I'll be showing you two models, but we'll be using the random forest model to be precise. So s- some of you might not have heard about the models, right? So the decision tree and the random forest model. So I'm just going to give a brief explanation of these models, and that's why I mentioned that you don't need to really understand about machine learning before coming to this webinar. So let me just switch, and yep. So can you see the Medium article? Can someone yeah, I'll be recording the session. Can someone confirm if they can see the Medium article?
Yes, we can see it.
All
Yes, we
right,
can
thank
see
you. And yeah, so the first model we'll be learning about is the decision tree regression model, and it's basically a model which is a supervised learning model. Supervised is basically it learns from other data, and it basically predicts on new data, and it's used for both regression and classification tasks. And this is a really good visual description of the regression decision tree model. So you have a root node over here followed by two interior nodes. So I'll be coming to what each of these nodes does, and the last node over here, right? So if you have you can see the last blue boxes over here is basically called the leaf node. It's like an inverted tree. So if you just think about it, right, so it's like an inverted tree where you have the root on the top and the leaf on the bottom. So it's like an inverted tree, and for each particular data point it's completely run through the entire tree. So this is a particular tree, and it's run through the entire tree answering true or false questions. So you can see that we're basically answering true or false questions until it reaches the leaf node. So if let me show an example. So you can see that if the salary is between 50,000 and 80,000, so if this is yes, then it goes to another question, and then it checks if it's yes or no, and if it's no, it just, like, if the office is not near the home, it just declines the offer. So it goes on doing this until you reach the last node or the leaf node. So this is the decision tree model, but what is one of the disadvantages of this model is that it may fail when we have an overfitting problem. So as I mentioned before, right, so if the p-value is something like 0, which is very peculiar, so the data might be overfitted with the model. So it might do very well on our training set, but it acts really strange when we give some alien data to it. So to tackle this problem, we'll basically be using the random forest algorithm. All right, so I'll just show you the random forest algorithm. So random forest is basically many decision trees combined, and you can see that we have one decision tree here, we have one decision tree here, and we have another decision tree here. So we have n decision trees over here, and then we are just going to combine and like summarize it. It merges the output of the multiple decision trees. So you clearly don't need to go into so much depth over here, but you just need to remember that we can give an input to the number of trees which you can have. So here we can give tree 1, tree 2, tree 3, tree 4, and so on. So we can give the number of inputs, and we can also specify how deep. Okay, so how deep the tree should go. So basically specifying to what distance the leaf node should be there. So we are doing that using the random forest algorithm, and I have a small image as well over here. So in our case, if the caret value is more than 5 but less than 7, so it should do something. If this is yes, then the price should range between 4,000 to 4,500. So this might not be true, but like I just shown you as a representation over here. So if it's no, then the price will be somewhere between 6,000 6,500. So this is just representation, and it shouldn't it's not necessarily true, but we'll have a range of questions like this. So this is one decision tree, so we'll have a second decision tree here, and so on till n decision trees, and you just merges the output of all the decision trees. So you don't need to know how it merges or how it forms questions, but this is the basic theory behind uh, the the models that we will be using. And let's now move on to the model training part, and now we're just going to implement all this in the form of code. So I don't see any doubts over here, so I hope you guys have understood about the decision tree and random forest, the models. And the as usual, what we are going to do is import our particular libraries over here which we need. So Streamlit and pandas is, we are already familiar with it, and sklearn is a library that helps you implement models really easily with just one or two lines of code. So here you can see that I've imported the random forest regressor model. So random forest regressor is basically a class of sklearn which allows you to implement your model in a very few lines of code. So it just abstracts the details which I just mentioned right now, and it like processes your model with around like a very few lines of code. So the first thing that we are doing over here is in taking the input for diamonds.csv and for new diamonds.csv. And the next thing that we're going to do is convert all the values, the categorical variables, right? So cut, color and clarity are categorical variables, so as you may have noticed in the practice project as well. So we are just going to convert these values into numerical values. So it's basically going to convert everything to zeros and ones. So this is similar to the select tool which you used in the Alteryx project as well. So since we are going to use our regression models, right, so it shouldn't have any categorical variables in it, so we should always have numerical type. So get dummies basically converts all the categorical columns in our data set to numerical data, so in the form of 0 and 1 to be more precise. And the next thing that we're going to do is just build a container for our model training. So containers also we have come across multiple times, and now I'm just going to write a header and just going to describe about the particular the model training. So what it's going to do is just going to take the input parameters from the user and train the model, and then we are going to test it on the new diamonds data set. So the way you're going to create columns, so now basically what I'm going to do is since we created rows or the containers, right, so in the similar way we can use beta columns to create columns in our application. So here you can see that I've created one column, it's called the selection column, and the other one is display column. So I'll be explaining what each of these columns does, and I've just created two columns using the beta columns. Do you compare the random forest solution? No, I won't be comparing it in this particular session, but you can always raise a pull request in my code, and you can write some code to compare both the functions gens. So yeah, so you can just create two columns over here. So I'm doing one for selection and the other one for display. Now what I'm going to do is a neat little trick. So I'm going to show the user the list of all the features which are present in the dataset. So features are basically columns which are present in our dataset using the diamonds data dot columns. So it's really simple. So pandas allows us to show us the columns as well. So you can use diamonds data dot columns, and it shows you a list of all the columns over here. So let me just run the application and show you, so it'll be clear that time. Oh shit, okay. Yep, this is the right file, and I'll just show you. If you have any other questions, you can go ahead and put it in the chat, and then I'll be sure to clear it. Yeah, so it's running. Yeah, so here you can see that we have, here is a list of features. So we're just showing it on the screen, and we're showing, hey user, you can select any of these features over here. So you can select caret, cut ordinal, color, and so on, right? All these features you're just going to select. So price is one feature which the user cannot select. So this is a small bug over here which I'll be fixing. So price is something that we are predicting, right? So based on the other features, so this is something which he cannot select, and basically shows you a good description of all the features. And you can see that we have one column, right? So here is an imaginary line. You can draw an imaginary line over here, and we have two columns. So here is one column where we can show the user what are the columns that you can select. And now what we're going to do is basically I'll just show you the entire application, and then let's go over the code really fast. Yeah, we can show it using the types also, so these are some of the ideas which I got, but I just kept the code simple so that everyone can understand. And you can raise a pull request if you want to include that in the code as well. So I'll just show you all the things that we are implemented over here, and then we'll look at the code real fast. Okay, and then we'll move on to the most interesting and most awaited part, which is deploying or building the like launching the application to the world wide web. Okay, so here what you can do is basically type. So we have a text box over here, like you do it in HTML as well, right? HTML or CSS. So we have a text box where you can type which feature you want over here. Caret is one feature that we'll be taking over here, but you can even implement various features, right? So you can give caret, cut, and you can just give multiple text boxes over here for 3 or 4 features, and you can do that. And for simplicity, I've just used caret over here, so you can just use caret and press enter. So now caret is our input feature. And now, as Sauro mentioned earlier, right, so about the sliders and all those things, so here you can see that we have a slider. So as I mentioned before, by showing you the diagram, right, so the max depth is basically the depth from the root node to the leaf node. So if you just imagine an inverted tree with the roots on the top and the leaf on the bottom, so max depth is basically how deep or how many questions we should ask in order to reach a conclusion. So here the max depth will be 1, so because we have only one question which is being asked. So if you have n questions here, right, so the max depth will be n. So here I'm just specifying that if the user for some reason doesn't want to specify his max depth, right, so we are going to take the default value as 20, and you can just hold over here and slide it, so 30, 40, 50. So this step, so the minimum number of steps you can take, like the increase, is going to be 10. So you cannot increase less than 10. So I'll be showing you in code also how to do this, but you can select the max depth, and you can see that automatically, right? So our price value, so I'll just come to this later, and we can also select the number of trees as well. So this is some terminology which I explained a couple of minutes back. So trees are basically, so this is one tree over here, and we can have another tree something like this over here, so another tree over here like this, and so on. So you can just imagine that a number of decision trees makes a particular random forest. So it's basically like simply saying like number of trees makes a forest, right? Even in machine learning as well, so number of decision trees makes a random forest. So it's a good analogy over here. And random is, if you may ask, what does random mean, right? So random basically means that there's no particular order in which it chooses the questions. So here if you see that if caret is more than 5 but less than 7, right, so this can appear on the second tree, it can appear on the third tree, fourth tree, and so on. There's no order in which the questions get chosen. So this is what random stands for. And yeah, so we can select the number of trees. So here I've given 3 options, so we can either select 100 trees, 200 trees, or 300 trees. So if you don't select any tree, for example, if the person doesn't want to select number of trees, right, so he can the default value is going to be 100. And now here what we are displaying is that is the new diamonds dataset. So in the new diamonds dataset, if you recall, we didn't have the price column, right? So price column wasn't there over here, and we just had the caret column. And now you can see if we change the number of trees, so the application runs again over here, It's taking some time, and you can see that the price changes. So if I give 200 trees and it's running again, so here the price is 6919. So you can see that the price fluctuates because the inputs to our model, right? So the maximum depth and the number of trees is the input, so it's going to change. So as and how it changes, the price also changes. And you can check the accuracy of the model using some more functions of Streamlit, some more functions of scikit-learn later on, and you can see that the price changes. So this was a brief about the application. And yeah, so it's Saurav says that it's named random because of the random sampling of training data points. So that's some terminology of over here which Saurav has explained. So thank you, Saurav, for doing that. And now let's briefly look at the code. So you don't need to understand all this code right here. So I'm just giving you a caution because you just need to know the power of Streamlit. So what it can do with just very less lines of code. So here, as we've seen, I'm first going to take where is that? Yep, here. So as you've seen here, right? So we are first going to take the input for the feature using a text box. So yeah. So text input, right? Text input is a function of Streamlit which allows you to take certain inputs, and you can give the name, like suppose over here we need this description of the input box, right? So which feature would you like to input to the model? So that's going to be the first parameter to our function over here, which will be displayed onto the screen. And the second one followed by a comma, the second one is going to be the input feature which is default. So if the person doesn't enter any feature over here, right? So it's by default it's going to be caret. So caret is the default value. So this is how you do a text input with just one line of code. Similarly, you can also specify slider. So slider over here, it just follows the same procedure. So here we give the brief description of what slider does. So you can see that what should be the maximum depth of the model. So the user can enter the maximum depth as a slider. So you can see that it enters as a slider, and over here you can see that our minimum value is going to be 10 and our maximum value is going to be 100, and the minimum number of steps or the increment which you can take is going to be 10 again. So I just specified it in very simple code. So you can see that minimum value is 10, maximum value can be 100, and the default value, so by default if the person doesn't choose anything, it's going to be 20, and the step, so the minimum increment is going to be 10. So this is how we take the maximum depth. And since we have to like select the number of trees, right? So this is basically selection, either 100, 100, 200 or 300. So you can see that we are basically using a select box, and we're giving the options to the user. So you can see that we are giving 100, 200 and 300, and we are specifying the index. So index is a terminology over here which I clearly didn't understand, because value is quite simple, right? So if the user doesn't select anything, then it's going to be 20. Similarly over here, if the user doesn't select anything, then the default value is going to be 100. So this is an array over here, and we are specifying the index is going to be 0 by default. All right, so now that we have got all the inputs for our model, here all we are doing is that we are calling our model with the maximum depth. So random forest regressor is a function of is a class of scikit-learn that allows you to define the maximum depth. So you don't need to understand this. So if you're not into machine learning, you don't need to understand the code, but I'll just go over it in brief. So we're just telling that the maximum depth should be equal to the maximum depth which has been specified by the user, and the number of trees should be the number of trees that are being like input by the user as well. So here we are just going to specify that, and the predictor variable. So predictor variable is basically the variable which we are going to use to predict something, right? So the variable which is used to predict something is called the predictor variable, and in this case the predictor variable is going to be the input which the user has given. So over here you can see that the input is caret. So we have stored caret in another variable, so it's going to be input feature. And if you give some other name over here, so let's say cut or cut ordinal, right? If you do that, then it's going to store the input feature as cut and cut ordinal. But here, since we have given caret, right, so it basically stores the input feature as caret, and this is going to be the variable which we are going to use to predict the price. So our target variable is going to be the price. So since you're going to predict the price, our target variable is going to be price. So we are just setting that to the particular columns, and diamonds data is the diamonds.csv file. So that's going to be the file that we are going to use. So there are a few doubts over here, but I'll just clear them in a couple of minutes. And now what we are going to do is we are going to train the model. So you don't need to remember the functions, but you're basically going to remember that or understand that. Now we are going to tell the model that, hey, for this caret value, this is the price. For another caret value, this is the price. So we're just going to train or teach the model that this is the price for this caret value, this is the price for another caret value, and so on. So we are just going to train the model. And secondly, over here, we are going to predict, give some other new alien data. So the new alien data over here is actually the caret column of our new diamonds.csv. So this is going to be the caret column from the new diamonds.csv. So as you may have remembered, new diamonds.csv doesn't have a price, right? So here we are going to specify the caret as the input feature. So now we are going to basically tell the model that, hey model, so I'm giving you a new set of values of caret, and you have to predict the price for it. So after we have trained the model, after we have taught the model something, this is like a test for the model. So this is where it does the prediction, and now we have to create another column. So in our new diamonds.csv file, we are going to create another column called price, and we are going to store the predicted values. Like here we are going to basically prediction of the price of the prices, and here we are going to basically show the prediction of the price for the new diamonds.csv. And so you can basically remember that this is like you're in a lecture hall, and if the teacher is teaching you to do something, and so basically over here you're doing that. So training the model, or you're just taking in information in your brain, and over here it's like a test for you. So you're just going to predict it, give the model some new information and tell it to do some prediction. And over here we are just going to create a new column called price in our new diamonds.csv. So you can see that there's a new column over here called price, and we are going to store the predicted values of the price in that column. So it's pretty much simple over here. You can do this, and after that, like always, we can also display the information that we have got from the model using st.write. So here I'm just going to call new diamonds data, and I'm telling it to just print the caret column and the price column. So we don't need the other columns, right? So there are many columns like cut ordinal, which we don't need as of now. So all we matter to us is caret and price. So we are just going to print the caret and the price column over here, and head, as you may have remembered, is going to print the first 5 records of the data set. So that it's over here. So you can see that we now have caret and price. So this is the data from the new diamonds.csv file. So caret is the number, the double value which wasn't known to the model before, but now it's predicted the prices after we trained the model. So if we change it to 60, you can see that the values over here will also change. Yeah, so you can see that the values over here change. So this wasn't that they are necessary, like you don't need to understand all this code. I'm going to show you an application, a demo of an application which does not use machine learning. So if you're into data analysis, just visualization of data, right, so you can build an application similar to that as well. All right, so now let's come to the most interesting part. So as we don't have much time, I'm going to just not tell you about the linear regression model over here, but you can find the code in the GitHub, and if you have any questions, you can ask me in Slack or through LinkedIn as well. So now we are going to deploy the model on Streamlit. So let me just go over the steps over there as well. So the first thing you have to do is go to just a minute. Yeah, so the first thing you have to do is go to streamlit.io / sharing sign up. So you have to go to this website and you have to get an invite for Streamlit sharing. So Streamlit sharing is basically the application or cloud server of Streamlit, which allows you to host your app on the internet. So you can use Streamlit sharing for that, and you can sign up for that over here. So it has a really easy sign up, and in a couple of days you should get an email like this. So you'll just get an email like this saying that your sharing invite is over here. So after this email is here, you can deploy your application. So the first step you have to do is this, and after that what we are going to do is add a requirements.txt file. So currently we don't have a connection between Streamlit and our local server. So local server is basically a system, and we don't have a connection. So Streamlit doesn't know exactly which Python packages, like we are going to use Streamlit, we're going to use pandas and so on, right? So Streamlit doesn't know exactly which packages we are going to use in our project. So for that, we are going to create a requirements.txt. So it just basically tells Streamlit that, hey Streamlit, these are the packages which we are going to use in our application, and you can find it in the requirements.txt file. And there's a simple Python package to do this as well. So it's called pipreqs. So you can install it using pip install piprex. So if you have Python installed in your system, then pip will be already installed in your system as well. And now once you have that installed in your system, right, so you'll have to run just one line of code. So it's basically says piprex followed by the file location. So pipreqs piprex followed by the file location. So if you want to have the requirements.txt file in the particular folder in which you're in right now, so you can specify ./. So ./ is for the if you want to have the requirements.txt file in a particular folder, and if you want to have it in some other folder, then you can specify the path over here as well. So it's pretty simple. So you do piprex followed by the name of the path. So I already have this should generate a requirements .txt file automatically for you. So it takes a couple of minutes, and I'll just show you how the requirements.txt file looks so that you know what exactly it's going to do. So here you can see that we have all the packages which you're going to use. So you can see that we have matplotlib, pandas, Streamlit, Seaborn, scikit-learn, and SkyPy, and it also specifies the version. So this file is basically going to tell Streamlit that I'm going to use these packages in my application, and in the background, right? So Streamlit automatically runs all this, imports all these files into its server, and you don't need to install it on Streamlit again. So it's a really wonderful thing over here using only this file. All right. So does anyone have any questions regarding the use of requirements.txt? So I'll be done in another 10 minutes. So I think it's going to overshoot a little bit. So I'll be done in another 5 to 10 minutes. So I'm not seeing any question over here. So I think all of you understood the use of requirements.txt. Yeah, we can also, okay, it's Saurav Kumar has answered Antonis's question, so let's just proceed. And now here what I've done is all the code from 1, 2 and 3, right? So all these files I've just compiled into one single app.py file. So all the code over here is basically compiled, and all the code from here is compiled into one single file. And I have two additional things over here. One is you can basically include a YouTube video as well in your in your application. So you can give st.video followed by the URL link. So here you can give an explanation of your project in your own words. So the user can click on the video and see the explanation of the project. And the second one which I've done is included a link to the GitHub. So you can specify link is equal to, and this is just the markdown syntax to specify the link, and I've given the link to my GitHub profile over here, and using st.markdown you can print it to the screen. So you don't need to remember all this. I just did a quick Google search, and I'm not bothered about remembering the syntax, but these are two cool things which you can do. And now let's get on to the hands-on part and actually deploy our application. So all right, so I think the first thing you have to do is go to github.com/your profile, and you have to go you have to click on the plus icon and go to new repository. So repository is basically the place where you'll be all your files are going to be stored. And here I can say diamond price spread. So I'm just going to give the repository name, and you can give a description over here, and also add a readme file. So readme file is basically going to tell what your particular project is going to do, and then you're going to just click create repository. So now you have a place where you can upload all your files. So what exactly you need to do is basically go to your file location, and I'm sorry if this extending beyond 1 hour, but so you need to go to your file location and copy all the files over here. So as you can see, I have all my files which we just discussed about now, right? So you need to just keep this ready, and you have to go to add file. So once you click add file, you can see the options upload files. So you need to click upload files, and you have to just drag all these files over here. So okay, Saurav Kumar is enjoying it, that's all right. So I usually keep it to less than 1 hour, but this is a really good topic, but it's going to take some time to explain as well, right? So it's just extending. So you can just upload all your files over here, and I'm just going to give a quick message saying that all files uploaded. That's it. All right, and now I'm just going to commit all the changes. So you don't need to know about these technical things right now. You can also refer back to it later, and if you need some resources to learn Git, I can tell about it later as well. All right, so now you can see that all our files are over here, including the requirements.txt file. So this is pretty much important. And the next step you have to do is go to the website share.streamlit.io. So once you got your invite ready, right? So once you got the email saying that, hey, you congrats for your invite. So it just shows you an invite. It just shows you that your invite has been accepted, and now you can start you're deploying your application. So you have to sign in through your GitHub account. So this is why you need a GitHub account over here. And once you signed in, you can see this kind of interface. So you'll have your app. So this website is share.streamlit.io, and you have your apps over here. Now it's just 2 clicks of a button, like literally 2 clicks of a button. So you just go to new app, click new app, and you go to repository. So repository is basically like a folder where you keep everything in one place on the internet. So go to repository and you select. So you get a drop down menu. You don't need to type the name of the repo as well, so you can just select from here. So our repository is going to be diamond price spread. So this is our repository, and the branch. So branch is, you can see that it's somewhere here. Okay, you can see if you see here, we have the main branch, right? So you don't need to know about branches right now, but it automatically selects the branch for you. So here you can see that we have main branch, and you select the branch over here. So whichever branches here, you just select it. So and here is the main part. So main file path is the actual file which you are going to be showing to your user. So app.py is the file, I mentioned that previously, that I've compiled everything in one file, right? So app.py is going to be that file which has all our sections over here, and like all the front end display, the text, the place where you're going to input the features, all that is in this file. And now I'm just going to select app.py over here, and I'm just going to click deploy. So this is the one click I was just talking about. So click deploy. That's all. So if anyone has any questions, quick questions, you can ask, because this is going to take some time. Now our app is in the oven, it's baking, so it just shows this nice like food over here. It's really tempting. And okay, if you have any questions, you can just ask. I'm free, so I'm hoping that you guys are enjoying this session. And it's all right if you haven't understood everything over here, but yeah, now we have balloons, so our app is successfully deployed. So you can see that how beautiful it is, right? We have our header over here, then we have a video description of the project, we have a video. So I've just put a random video over here, but if you're employer, right, so if you're going for a job interview, he asks you to say what does your project do, so you can just show him this video over here, and you can see data sources. All these things are what we did in the local, right? So over here, see, this is localhost 8501. So if you share this with someone, then they won't be able to see what you'll be seeing right now. So you can see that we have the description of the data set, and you see that we get beautiful plots. So we have this mind-blowing plots over here, and the correlations. So all these are the things which we covered. And it also works over here. So if you change the drag, and if you see the max depth of the model is 30, you can see that our price changes. So it's really very nice. And now this is something which I didn't show in the presentation right now when I was explaining, but you can also do a linear regression model, and you can see that our bid price over here is really similar. You might remember it or you might not remember it, but it's quite similar to the bid price that we got from the Alteryx model as well. So now you can see the difference, right? So if you give a Alteryx model to someone, and so if you give an Alteryx model to someone and tell them, explain them about your application, right? So they are not going to understand that properly. But if you give something like this, so this application which anyone can understand, right? If you build an application like this, then any person in the world who knows how to read English can understand and use our application. So if you click this, you'll just go to my GitHub repo, and yeah, so this was all about my presentation, and that's all I had to say. So if I'm open to questions now, so let's quickly take some questions, and then you can join Tharuka's session. So do you have any questions? Can ask your questions now. And yeah, but before you leave, right, just before you leave,
Voices.
I wanted to fill in the
And you mute yourself.
Yeah, maybe.
Oh, I'm sorry. Okay. Sorry. Yeah, but before you leave, just 1 minute. Can you all of you? Can you fill in the feedback form? Right. So please fill in the feedback form. I got really constructive feedback from everyone last time. So one of that was that I was speaking too fast. So I think I slowed down this time. And okay, so Streamlit does support user authentication, and there are a few really good. Tharuka if Tharuka is here, I think you can share the Zoom link for your session as well over here in a couple of minutes. And yeah, so Streamlit does support user authentication, and there's one more thing I wanted to show you. I'm sorry, I didn't show it to you. So if you don't want to use okay, yeah, so if you don't want to, right, so if you don't want to use machine learning in your application, right, you can just use even simple visualization apps as well. applications as well. So here you can see that I have an iris data set, and here I can see preview data frame. So if I click on preview data frame, it's going to preview the data frame, and if I click head, it's going to show me the first 5 records. And if you click show all data frame, it just shows you the entire data frame. And similarly over here you can see if I do simple bar plot with matplotlib, right? All right. Yeah, so if I do simple bar plot with matplotlib, you can see that we get a bar plot over here. So this has no machine learning involved. And you can also build an application like this if you're not keen in ML and you just want to stick to like data visualization. You can build an application like this as well. So okay, so please fill in the feedback form because that really helps me a lot, and I I really get motivated and get constructive feedback as well over there. So it's really very helpful. Yeah, I just shared the form a couple of minutes back, and the next session is going to be Tharuka's session on Power BI. So power of Power BI. That's going to be really interesting. And before you go, I'll just share the form again, and I'll just clear all the questions which everyone has. So hope all of you enjoyed the session, and I hope it was of help to you. And I will be recording the. I mean, I have recorded the session, and regarding the GitHub repo, I will share the repository here as well. All right. And I guess someone asked about any course for learning Streamlit, right? So I have one course, a really good YouTube channel as well. So I'll share it in the Slack server, and yeah. So this is the GitHub repo, and I'll be sharing it in the Slack server as well. And so that's all from my end. Like I don't have anything else. If you have any questions, you can stay back, or you can go ahead and join the Taruka session. So Power BI, just share the link over here. Yep, this is the link to the next session. And if you have any questions, you can reach out to me on LinkedIn. Claude, there was no presentation as such. I can share the recording. I'll share the recording with you after the session in the Slack channel, or I'll just upload it in the Google Sheets as well. So over here. So this is, I'll be uploading all the recordings over here. Yeah, thank you. You're welcome, Madelino. All right, and yeah, so I hope all of you had fun, and thank you, Sauro. So I'm glad it helped you, and you have to remember that you don't need to involve machine learning over here. So you can just build a simple to-do application or data visualization application as well. So okay, I'll be joining the next session now, so I'm really excited for that as well. So I'll just take your leave, and I'll share the recordings. If you have any questions, you can ask me in Slack or LinkedIn as well. So bye, good day everyone, bye.